Hello and welcome to Honors Function. This is the first lecture of a series of 3 on inverse function. Inverse function is a fundamental topic in mathematics. In this lecture, we're gonna define an inverse function. Let's start by looking at a relation. You know that a function is a very specific kind of relation. So let's first look at a relation and define an inverse relation. So here's, for example, is a relation that I called R right here. And a relation is a set of ordered pair. I have here some ordered pair. I know the domain of R. The domain of R is what? It's -3, -2, -1, 0, 1, 2, and 3, right? I just read the first coordinate of the point. What's the range of R? The range of R is 2, -1, 5, -4, -3, 2, I'm not going to repeat it, and 0. You don't repeat value in a set notation, okay? So here is the domain and the range of R. We also have, for example, what is R of 0? R of 0 is -4. What is R of -2? R of -2. R brings -2 to -1, right? So we also use this notation for relations. Okay, so what do we call the inverse relation of R? So it's very simple. The inverse relation of R is the relation that is defined by flipping all the coordinates of R. So right here you would have 2, -3. And then you would have -1, -2. Then we have 5, -1, -4, 0, -3, 1, 2, 2, I mean the flipping here doesn't really matter, and 0, 3. I've replaced my second coordinate by first and my first coordinate by the second. Every relation has an inverse relation, okay? You just flip the coordinate. Now what's the domain of the inverse relation? Well, the domain of the inverse relation is the range of the relation, right? It's this right here. It's the range of the relation because I flip my coordinate. And what's the range of the inverse relation? Well, it is a domain of the relation. Okay, so we have a flipping there to an inversion that happens. And also, what is R -1 of -1? Well, R -1 of -1 is -2, right? R minus 1 brings -1 to -2. And we also have that R inverse, we say R inverse, of -4 is, I'm looking at this point now, is 0, right? So, again, we have some kind of inverse thing that happens there. Well, it's called the inverse relation. So, in general, if AB is a point in the relation called R, that means R of A equals B, right? If and only if. Then what do we have? Then we have BA, that's necessarily a point in the inverse relation, right? So we have again R inverse of B equals A. All right? What's the geometric relation between AB and BA? So look, if you draw a graph right here, I'm going to do it quickly. If AB is here, AB, how can you graph BA? Well, look at the line y equals x right here. Y is x. Y equals x. I'm going to take A and I'm going to go on my y-axis. Here's A on the y-axis, right? And I'm going to take B and I'm going to bring it on the x-axis right here. Here's B. And here's the point BA. That's BA. While this is the point AB, right? So what's the relation between BA and AB? Symmetrical with respect to the line y equals x. That's going to be an important property, okay? The relation, the geometric relation, is that these 2 points are symmetrical with respect to the line y equals x, okay? Please check again this construction. To report a value from an axis to the next axis, you have to use a line y equals x. Y is x. It makes sense, okay? So before I tackle my first example, I want to go back to the relation we just covered, this relation right here. Is the relation R a function? Well, look at the input, -3, -2, -1, 0, 1, 2, and 3. I don't repeat any other input. For example, I don't have here -2, 4, right? I don't have it. That would not be a function because -2 would go to -1 and -2 would go to 4. Two output for the same input. But I don't have it. These inputs are only repeated once. So this is a function. How about the inverse relation? Is the inverse relation a function or not? So here's 2, -1, 5, -4, -3, 2. I repeated 2. So let me look at the output. 2, 2, 2, -3. No, that is not a function because 2 is associated to -3 and also to 2. It doesn't pass a vertical line test. So the inverse relation is not a function. The inverse relation is not a function. So we say that the function R, we just checked that R was a function. The function R does not have an inverse function. It doesn't have an inverse function. There is always an inverse relation. Here's the inverse relation, but the inverse relation is not a function. Therefore, it doesn't have an inverse function. It has an inverse relation. Let's tackle now the first example. So here is another relation right here. Let's check that it's a function. -5, 2, -3, -2, 5, 4, 0. I did not repeat any input, therefore it is a function. Does R have an inverse function? Well, I don't know. We need to look at the inverse relation for that, right? So what's the inverse relation? What do we have? We have 0, 5, -5, 2, 2, -3, -3, -2. Next, what do we have? 3, 5, 3, 5, and 1, 4, 1, 4, and -1, 0, -1, 0. Here is R inverse. Is that a function? 0, -5, 2, -3, 3, 1, -1. Yes, this is a function. So in this case, the function R has an inverse function. The function R has an inverse function. Okay? It has an inverse function, and the inverse function is R minus 1. All right. Next question. Plot R and R minus 1 on the system of axes. So I'm going to let you do that. Make sure you plot R with one color, okay? For example, -5, 0 right here. I'm doing it in black. And R minus 1 would be 0, -5 right here, okay, in blue. And you can see that actually these 2 points would be symmetrical with respect to the line y equals x, right here, same distance on both sides, okay? I'm going to let you do that. Let's move on. So this is what's going on. If you're given a function f, so suppose now that my relation given is a function. If I'm given a function f, I can always find the inverse relation by switching all my coordinate, and the inverse relation will be noted f minus 1. If this inverse relation, if it is also a function, then I will say that f has an inverse function, okay, inverse function. And I will say that f is invertible. Invertible. So again, you need the inverse relation to be a function to call that the inverse function. If the inverse relation is a function, then this is called the inverse function of f, okay? And you say that f is invertible. So, another example, if f of 1 is equal to a, right? F brings 1 to a, right here. F brings 1 to a. Or another way of saying that is 1a is on the graph of f, is in the function f, right here, why not use this one? Then we have a1 in f inverse, right? Or f inverse of a is equal to 1. So f inverse brings a back to 1, okay? And that's why an inverse function, we often say that it undoes what the function does. It undoes what the function does. F brings 1 to a, f minus 1 will bring a back to 1, okay? This is a very important property of inverse function, but let's get a couple more right here, okay? So suppose you take 1 and you bring it to a with f. Now this is a, right? So what happens if on both sides you apply f minus 1? F inverse. So this is f inverse of a, and you find what? F inverse of a is 1. So 1 goes to a with f, and then it goes back to 1 with f inverse, right? So f minus 1 of f of 1 is 1. And of course, you can check out that if you start at a and carry it to 1 with f inverse, right? So I'm doing f inverse of a equals 1 right here. And if I apply on both sides the function f, what's going to happen? Well, if you apply on both sides the function f, you're going to carry back 1 to a. F of f inverse of a is f of 1, which is a, okay? So we have three very, very important property of inverse function, which I'm going to write right now. The first one is, if f carries x to y, then, and actually it's an if and only if, f carries x to y, if and only if, f inverse carries y back to x. That's the first very important property of inverse function. The next one is, if you take x and you put it in the function f, and then you put this one in the function f inverse, you're back at x. And the same thing happens if you first plug x in the function f inverse and then plug this in the function f, you will be back at x. These guys are the very, very fundamental property that you will have to remember until the end of the year, not to say the end of your life, about inverse function, okay? Very, very, very important. Now, of course, the immediate question right here is, when does f have an inverse function? When does it have an inverse function? And then the following question, if it does, what's the expression? What is f inverse of x? Can I find it? And also the graph, and the graph of f inverse, okay? So this question, we're not going to answer this one in this lecture. When does it have an inverse? And what's the graph of the inverse? And what's the expression? We're not going to answer this one in this lecture, but in this lecture, we're going to look at, as I said, we're going to look at the definition of an inverse function. So the definition I gave with the inverse relation is really not satisfying, because you don't flip coordinate, right? You don't flip coordinate. So to define an inverse function in a more satisfying way, we're going to be looking at these two equations right here, okay? So let me bring the definition of an inverse function right now. So I don't often read my note, but this statement I'm going to read. If you are given a function f, okay, from a to b, and if there exists a function g from b to a, such that g of f of x equals x, and f of g of x equals x, then f and g are inverse of each other. If you have this, then g is called the inverse of f, okay? G is f minus 1, or if you want, it's the same thing. F is g minus 1, okay? There's no difference there. G and f are inverse of each other. So basically, we're looking at the, as I said, we're looking at the last two relation that I wrote about an inverse function, right? F of f minus 1 of x. This has to be equal to x, and f minus 1 of f of x has to be equal to x also, right? If I do have an inverse function, we take this and we fit it into a statement to define an inverse function. If this happens, okay, with these two equality, then f and g are inverse of each other. Let's go and work out some examples right now. So I'm going to do number 2, and then you're going to do number 3 and number 4, okay? So what's going on here? I have a function that has an inverse, okay? It has an inverse, and I know that f of 2 is 5. So, clearly we should keep in mind that f brings 2 to 5. That's what f does. All right, and I'm asking you for f inverse of negative 5. I'm sorry, I forgot the negative sign here. It's negative 5 right there, okay? F inverse of negative 5. Well, f inverse is this one right here. So f inverse of negative 5 is going to be 2, okay? Now, what is f of 2 and this right here? Guys, do not confuse this power negative 1 here with this one, right? This is the inverse function, okay? Well, this is not the inverse function. This is a reciprocal function. Okay, this is a reciprocal function. The reciprocal function, f of x negative 1, is just 1 over f of x. It's a reciprocal of f of x, okay? So this is just the reciprocal of, this is 1 over f of 2. So it is 1 over negative 5, all right? So done with this, done with this. Oh, what about this one, guys? So be careful here, okay? This is the, okay, let me take it here. It's the inverse of f inverse of negative 5 reciprocal. So I'm going to start with this one. This is the reciprocal of f inverse of negative 5. And f inverse of negative 5 is 2, so it's just 1/2. All right? Okay, you do example number 3 and example number 4, please. And I'm going to do example number 5 now. So this example will be based on the definition I gave you of an inverse function. I have to prove, so I'm telling you there are inverse, prove it. So this is very easy. I have to do f of g of x, and I know what I must find. I must find x. So let's plug in. 2 times x plus 3 over 2 minus 3. So these two will cancel, and I have x plus 3 minus 3, and that's x. Minus 3, and that's x. Okay, it checks. That's not enough, okay? You need to check the other one. G of f of x. So this is 2x minus 3. This is f of x plus 3 over 2. So it is 2x over 2, so it is x. Yes, it checks out fine. You do number 6, and I'm going to do number 7. So I need to prove that f is its own inverse. Well, that's okay. I need to prove that f of x is equal to x, and I don't have to check the other one because it would be the same. So is that true? I don't know. Let's see. Let me plug f of x into itself. So x plus 3 over 2x minus 1. This is f of x, so plus 3 over, so 2 times, and then x plus 3 over 2x minus 1 minus 1. Okay, now I think you know what I'm going to do. I'm going to multiply both sides of this fraction by 2x minus 1, just to make my life a little bit easier. 2x minus 1 right here. All right, so let's expand this. What do we have? I got to distribute, right? So I multiply this like this, and then I'm going to multiply this like that. So in the first one, you cancel the 2x minus 1, so you have x plus 3 plus, and here let's distribute that, plus 6x minus 3. Here we go. And at the bottom, what do we have? So these two will cancel here, but you still have a 2 in front, right? So it's 2 times x plus 3 minus, careful right here, you got to distribute, minus 2x minus 1. Here we go. All right. So what is this? This is 7x at the top, 7x, divided by 2x plus 6 minus 2x plus 1. So it is 7x divided by 7, and that is x. Okay, so yes, f is its own inverse. All right. So guys, one thing you really have to remember that I'm going to be using all the time is if f has an inverse, you have 3 relations. Here, I'm going to use, if you remember this little diagram, it's pretty simple to get all the relation. F brings x to y, while F inverse brings y back to x. So how do we express that with free relation? Here we go. F of x is equal to y if and only if x is equal to F inverse of y. Input becomes output, output becomes input. Or, second relation, which is equivalent, F of F inverse of x is equal to x, or, lastly, F inverse of F of x is equal to x. So this is the end of the first lecture. We just looked at the definition of an inverse function. We haven't checked when a function has an inverse and how to figure out what the inverse is. We haven't checked that, okay? We're going to do that in lecture 2 and lecture 3. Please read these set of notes very carefully. Thank you for watching.